So now I wanna dig into the topic of setting actual values and displaying it back to the DOM, at least not to the DOM first, but to the render cycle. So that actually needs to have two things in place. One of them is being able to modify the memory state here, and the second one is actually trigger rendering. So what we want to do is the current hook queue, if it doesn't exist, that means that the initial render cycle, and the other case will be just simply the case when so later on setting a new value will simply be pushing a new element to this queue. So what we need to do is get the most up-to-date value, which is really easy stuff. It's just memory state equals, because the memory state will always be the value, so memory state will be equal that queue, and we'll need to have the latest element, which is just simply so that's how we can grab it. So it's pretty easy stuff, and we need some way to push it onto the queue. So we have this setter function, and the setter function either takes a value, right? So what we ideally have is we have a function which will take a value and do something with it. So console log value out. So we can now replace it with setter. Okay, what is not defined. So now if I click on increment, now it console logs it out. Problem is that we need to have access to the current hook, and the problem is that like here in the useState it is guaranteed that the current hook will be up to date, but the rendering cycle is done. We clear the fiber, like the global fiber here, and there will be no guarantee that we will have access to the hook or to the fiber at the time when the user, for example, clicks on increment and triggers an actual event handler. So that's where we can leverage JavaScript lexical scope, and we can use currying. So if we do something like we can carry this function over, and if we not directly invoke it, but actually we call a row setter with the current hook, that this we will have access it here, and this reference will not gonna be deleted, right? So it will we will have access it like any time. So what we can do, we can still console log the value out, so it's gonna work as expected if that's our only goal, is just console logging things out. But now we can access to this variable, and what we can do now is we can push the queue, push value. So now we can push the value onto the array. Yeah, the problem is it's not gonna trigger re-render, so we need to trigger re-render from other parts of the application so we can see the actual fiber. So this is the actual fiber, and now you can see that the queue has 12 elements. So it pushes onto the queue, but it doesn't update anything, so that's a problem. But this can be solved by just simply, so this is the exact same thing with the component in the update schedule. So if we go to the component, we have this update schedule thing, or schedule update or whatever, and this is basically putting another task onto the task queue and starts a rendering cycle. So we need to do the same thing with the hooks as well. So we need schedule functional update maybe, and we don't have partial state at this time, but we only have the fiber, so we need to update some things here, and instead of instance and partial state we need to pass the fiber down. So that's gonna be schedule functional update, and we need to import it here. So import from okay, so after we push the new value, we need to render things. So I have no idea what I'm doing. Schedule functional update with the fiber. So now it pushes a new value onto the queue, and we need to re-render it, and the next time we render it, it will obviously trigger a new call to the useState, and the useState will be picking up the latest value because it will get the value from the end of the array, and so it will our new value at the end of the array will be like kind of fed back to the component itself. So if we click on increment, it says fiber is not defined. Yeah, because we don't have a fiber, so we don't just need the current hook, we need the current fiber. Okay. Now it says root fiber container is not defined, which is because in so it's going get first subtask. Yeah, it's here. So we need to create a different solution. So it's if it's coming from a fiber component, then we won't have a partial state, and we need to traverse the root, but we have only a fiber, so task.fiber, but the instance was an object which had a fiber field, so we need to kind of trick this traverse root function thing that we are passing an instance onto it. So now if we increment it, it triggers a render, although it doesn't change the value there. Okay, that's interesting. I think it's because current hook is not set to null at the cleanup phase. So now, if we increment it, now we get back the correct value, and if we trigger another re-render, it's not gonna get changed. So what if I set greeting to morning, increment? Okay, so I think it kind of works. Okay, so I'm gonna get rid of that one. So we won't have, what's that index.js 79, that is from here. I can get rid of that. Okay, so I think we managed to make it work, at least the useState. I know it might be overwhelming, so that's the reason why I just like to go through everything and maybe create some comments. So let's write. So this is the work in progress fiber at the time the hooks are called. Okay, so current hook is this is the this is the, let's call it state machine implementation of the current hook being called. So that is why the order matters. So the order of calling the hooks in the client side, in the client, matters because it has a fixed order in the fiber implementation of it. Okay, so as I said before, that's why we can't have any if statements. So you need to declare your hooks on the top of the functional component, and on the initial render, that's how the algorithm will create the proper order of linked lists that keeps track of all the states that we have for the given hook. So get next hook is okay, so keep sets the current hook to sets the current hook, or creates one if it's the initial render to the appropriate one given the order how they were described in the client. Okay, so that's what it does is basically, so we have the sort of linked list implementation in the fiber, and the get next hook is make sure that when you call the useState or useEffect or whatever, you will get back the current representation, so you will have all the previous states and queues and whatnot, and you will have access to the next hook. So prepare hooks is sets the VIP fiber, clean hooks is it clears both the fiber and hook global wars. Okay. So it takes a hook and takes a fiber, takes an arbitrary value and returns nothing. So creates a function that can be called outside of the context, pushes a new value onto the queue and triggers a re-render. useState takes something and it returns that signature. Okay, so first it gets the correct hook, and well, I don't really think that's what we need to write down. I'd rather get into it later on. So okay, so it takes a function does it take? That function has a signature of React element, and it will return a React element. Okay. So okay, I think that's quite okay. We have these function signatures, and let's just go through what's happening from the beginning of the things. So first we are creating a fiber when it's the initial render. Okay, so that's the initial render. If it's a functional component, the memory state will be set to this structure. Then this fiber will get to the to this part, and eventually we'll get to the fiber tag equals functional component. And now, instead of just simply returning a call with the React elements, we are wrapping it into this update functional component. And the reason why we need to do that, because when we call the actual function, we will be invoking the useState, and the useState needs to have access to the current hook and the current fiber. And the way to do it is wrapping the actual function invocation between prepare hooks and clean hooks. So prepare hooks is basically getting the currently so the work in progress fiber. The work in progress fiber is set here. So by the time we get to this line of code, it is already in some kind of a global variable. So we're taking care of that here. So now we can call the function, because when the function gets called, we will know that what the VIP progress is. So get next hook will have access to the current fiber. So if there is no hook, that we're just grabbing the memory state. Okay, so that's the first. Let's assume that that is the first use state, and that's the first render. So the queue is undefined. We're creating the queue, and we're setting the memory state to the initial state, and so we're setting the value here that's gonna get returned, and we're setting the setter. So the setter is basically needs to have access to the hook and needs to have access to the fiber. The hook will be required when we will be pushing new values onto it, and the fiber will be required when we are scheduling an update. And yeah, we need to have this kind of thing here, because we need to have access to these variables even when we are out of this context. Okay, then assume that comes the next state, which is the greeting. So we're calling the get next hook again, and since it is not undefined at the moment we come in here, and since it's the initial render, the next is undefined, so we're creating the next structure, and we are just simply like traversing it to the next. So the current hook will be the current hook dot next. Okay, so when it's done, it is still the initial render, but just for the greeting hook, we are doing the same thing. We are setting the value, we are creating the array, we're creating the setter, and we are returning it. Okay. All right. So let's cover the case when it's actually we're trying to increment things, or just trying to trying to set the value. So what's happening now is we again get into the render cycle, but a few things change. So they are still like null, because we had a cleanups state here, so clean hooks. We set both of the values to null. We returned the elements. So in the first render, elements were returned, the React elements, and the reconciled children created all the fibers along the way, but that's another story. So when we get to clicking on the button, what happens is the value that were described in the client got pushed to the queue, and we know what hook to use because we have reference onto it and we scheduled an update. So what happens is we will get to a point where we will call the begin task again because there was a new update triggered, and we get to the useState again. So, but just before getting into the useState, we're preparing the hooks. So we will get the current fiber, and we get to the useState function here. We're getting to the line 82. So get next hook will be giving us some different values this time. Actually it will, okay, so because in the previous render we cleaned up the things, so it's again undefined. We're getting the current fiber memoized state, but this time the queue is not empty. We have two values in it because we had the initial state and we pushed another one. So we're going to the end of the queue, we're getting the memoized state, we're updating the value, we're updating the setter, and we're returning it. There comes the greeting part. Now the current hook.next is not undefined because we have the memoized state and we have the queue with one initial value onto it, so we're just simply returning the next hook. And the same story goes here. So the queue is not empty, but we don't have any other values, so it's just an array with one value because that hadn't been touched in any way. So we're just returning the value and we're returning setter, and then both of the useState functions ran. We're getting the elements, we clean the hooks and returning the elements, and that's it. Okay, so I think that's for the useState hook. I hope it kind of makes sense. Yeah, so I think it works. It doesn't break things. So okay, so that's for the useState. And what I want to touch, I actually just want to touch another one, which is the use effect. Maybe useRef, but that's, I think, should be an easy one. And that's it. So see you next time, guys, and thanks for listening.